Okay, the last one. Here's the last one for tearing strength. This is another tearing strength for Elmendorf. This, in this test, we prepare the specimen like this. It's very important in this sharp. This two line is it's very important. This one and this one, this two line is very important because this length is 63 millimeter. And you know, in this equipment, we have a knife here. So we give him a slit here, 20 millimeters. So the tear length is about 43 millimeters. So be careful of this knife. And first, we put the specimen in the equipment and then use a knife to give the specimen a slit here. And then we start the machine. So we got the tiered specimen here. And we can got the data in the equipment. And this test is also only for woven. Okay, now let's.
Are there any control parameters to check the machine to know the result correct or not? Because
in the standard, it don't have this. We don't have this control fabric, but in your lab you can do it yourself.
Many of them and do correlation, and should do correlation between the labs, right?
Yeah. You can, for this equipment, you can calculate it by itself. It has some calculated loads. Yeah.
Any equation to calculate?
Equation to calculate.
Yeah. Some form. Way to check is it correct or not the result. I mean control fabric.
No control fabric.
Yeah.
Normally control by the internal method.
So the first time they buy the machine, they test the machine,
Yeah.
and they keep the fabric.
Yeah.
For some year they test that fabric.
Yeah.
You see.
Yeah. You can do it in your lab. You can do it in your lab. And there's another important thing is that look at this picture. The tear line is here. And look at this picture. If the tear line outside this angle is not very normal. Must be inside this scope. Okay, now we can do the test. Okay. Okay. Here is the test specimen, and here is the weft. We must choose the load type. 你选了吗? Okay, this is D.
They're automatic. No need.
The first one, and the unit is Newton, and the rate usually is 12 to 80%. Okay, secure the specimen in the equipment, and then we use a knife to give it a slit. And then start the equipment. And then check the tear,要拿下来检查一下那个裂口是不是在那块。Check the tear is in the scope, and then we will got the tearing strength here. Okay. Okay. This has.
这个
Why we slip it?
这个
Why we slip? Why we give it a slip? In the standard we have this range, because if the force is in this range, is be more 准确怎么说
accurate.
It's more accurate. The data will be more accurate. Mm. 我不知道怎么讲这个，如果你来讲这个，我讲不好。他们为什么选20%到80%的范围？其实是标准要求的，但是一般情况下，你对于仪器的量程来说，前面10%和后面20%这个都是不太准的，所以中间的范围内它是最准的，所以他才会选20%到80%的这个量程出这个结果。
It has this limit of the measuring range because at the near the maximum and near the minimum values of the measuring range, the value are not very accurate. So for best accuracy, we in the standard we requires to use the middle part of the measuring range, not the full range. Yeah, two choice, so 15% to 85 and 20% to 80%. Two choice of the limit of the for 80% of the maximum load. So if you're using like a 128, then it's 20 to 80% of the 128 Newton range. If you are using like the 5 Newton test weight, then it's the 20% to 80% of the 8 Newton range. So for each test weight, the usable range is in the middle. So if your specimen is like a 7.5 Newton result, but you use the 8 Newton test weight, then the software will tell you you need to use the larger weight. Yeah, then you change to the larger weight and then do the test, and it falls near the middle of the measuring range, and that's okay.
Okay, this.
Not every test. Not every test. No, but every one style. Yeah. No need to calibrate for each test. No need. No need to recalibrate when change, because you do the calibration for all the test range once, and then you can afterwards, in a period of time like several months, you can use the machine without. it's easy, but it should be done on a sturdy table. And we put it on a card, it's not very stable. So the calibration result, yeah, the calibration is only takes a few minutes. Yeah. The calibration of this machine does not need any external like meter, any other tools. Just the weight and then the test weight and the calibration weight included with the machine in the box. Okay. Yeah, for you verify the cutting distance by using like a piece of paper. You clamp it in the test like jaw. 20 millimeter. 20.
20 millimeter. You can use the paper to check it.
No need external. But even if
it has if we calculate this equipment, the calculator company will do it. We use the equipment standard. It has another standard for calculate.
So there's a standard calibration procedure. If you are asking the like a third-party calibration and like a certificate.
They will do all the. In our lab, in our lab we will calculate the slip distance of 20 millimeters and the load, maybe so on, just this.
They can only like a metrology speaking. They can only measure the cutting size, the distance between the clamping phase. But for the test result, there is no like a metrology standard, metrology procedure. So for third party, they have currently no way to do like a metrology calibration of the result. Not like using like weight or something like. They only have they only have metrology standard for the older, fully mechanical Elmendorf. For the digital, there is no.
No need to check the friction every day. No need. No need to check.
Friction is only after a long time. Like especially if you are not using the machine, like the bearing inside, the grease is like getting stuck. But if you are using every day, the friction usually is okay.